Hi friends. So in this tutorial we are going to learn about the relational and logical operators that we use in programming, and these are very much important operators, whether we are using looping or conditional check, or we have to use many a times to compare different things or to check out the values. So these operators are generally very important and it is important to learn about them. So before starting, let's see what these operators are. So if we talk about the relational operators, right? Since we have these two operators here, first we'll discuss about the relational operators. So the relational operators could be greater than, less than, greater than, equal to, less than, equal to. It could be something like not equal to or equal to equal to. Please note that this equal to is an assignment operator, but we have used to equal to. That is a relational operator, right? It's used for comparison, making comparison between the two operands. Okay, if we have two operands and we are using the relational operator, we are making the comparison between the two operands. Okay, let's see what are the logical operators. So, I'm sorry. Okay, just a second. Right. So now we have the logical operators. So let's see what are these logical operators are. So logical operators could be and, or, like and, or. So these are just the symbolic notations to write these logical operators. So we'll look more of them. First, let's discuss what are how these are important for our programming basics. Okay, so all the relational or logical operators that we discussed right now, all the relational and logical operators, when they are computed inside an expression, they return either they return either 0 or 1, the binaries. Okay, so that is why they are very important. So all the logical and relational operators return either 0 or 1. Now when they return 0, when they return true, when the expression computes to true, if expression is true, right, if the expression is true, then they return 1 and 0 if the expression is false, right? If we have the expression as false, then they return 0, right? So, what is the expression and how it is being computed, we'll see next. But for now, assume all the non-zero are considered as true. All non-zeros. Not in fact one, but all the non-zeros are considered as true. And for the false, all the zeros, I mean, there is only one zero, but all the zeros considered as false. Like if the expression computes to any non-zero integer, it is considered as true. And if the expression computes to any zero, it is considered as false. Okay, so this is the basic thing that we have to note. Now let's see what are the expressions and so. But before that, what I mean by these two sentences is we have the relational and logical operators computing either to true or false. We already discussed true means 1, false means 0. But there is a generic set to this, like all the non-zeros are also treated as true. Like 1 is true. Similar way we have minus 13 is also true. Okay, we have 8.5 is also true, plus 7 is also true. We have minus 3.5 is also true. But for false, if the expression computes to 0, it is a false. Okay, so this is an important thing to remember. All the non-zeros integers also evaluates to true only, are equivalent to true. Okay, are equivalent to true. Okay, and the zero part is equivalent to false. Okay, now let's see some of the expressions. For example, if we have a equal to 5 greater than 4. Now this is a relational operator, of course, we have talked about. Now 5 greater than 4, is it true or false? Of course it is true. So a is true, right? So value of a, if a is an integer, okay, if it is an integer, so a equal to 1 because it's true. Okay, right? So this evaluation, if a is we have already declared as an integer and 5 greater than 4 evaluates to 1, that is equivalent to 2. So a will be assigned an integer value of 1. Okay, let's see an example 2. We have a equal to 5 greater than equal to 5. This is a true expression, of course. So a is assigned as 1. Okay. Let's see another example. A equal to 5 greater than 4 plus 5 greater than 4. Now, these are the relational operators, and this evaluates to true. This evaluates to true. So, value of A will be 2 from this. Now, you can see here that this is a will evaluate to Boolean only. But the Boolean value when converted to integer, that is true, is equivalent to 1. True is equivalent to 1. So that's how it's got the value 2. Okay. Don't confuse with that. Okay. Let's see another example. A equal to 6 or 0. Now this is a logical operator we already talked about. And what this logical operator signifies to, it is an OR operator, OR. Okay. So 6 is basically a non-zero integer, that is a true, and 0 is basically a false. So true or false, definitely it is true. Okay, so if it is true, then value of a will be 1. Okay, now let's see another example. A equal to 5 greater than 4 greater than 3. Now see, again we have two operators and the same precedence. We need to follow the associativity left to right. So let's see if it is valid. 5 greater than 4, of course it is true. 1 greater than 3, of course it is false. So value of a will be 0. Note here associativity we follow, because if the precedence matches, we need to go for the associativity, and associativity of relational operator is left to right. Okay. So please note this in mind, because if you would start with this, then it will be evaluating to true, and of course it will be evaluating to true, then this values will be 1, and then it will be 1, and of course our answer will be wrong. So please note to follow the associativity if the precedence matches. Okay. Uh, let's see another thing. Okay, so this is all about the relational and logical operator. We'll be seeing more of them when we discuss about function, looping, switch statements and all. So this is just a beginning of that and a basic introduction that I would like to discuss. Okay, so that's all about that. We are more going to see this in the conditional statements. Okay, if else.